Okay, so Trent and I are both here from the company. If you have questions, difficult questions, go to Trent. So a few things I wanted to highlight here. And one useful thing about going last is that other speakers mention things that you remember that you were going to mention. And so what I wanted to talk about with this one is, we intend to go every year, and both Maria and Jack touched upon the fact that we're about to see regular visits to the moon. And I've been fortunate enough to attend every ELS in person, and I've seen it grow. And I was thinking, yesterday evening when I was going through the slides, this is the last ELS we'll have before we're starting to get brand new data from the lunar surface. And I think it's easy to underestimate how exciting it's going to be once ELSs are starting to be looking at data that have been acquired in the last year. And the one thing that a regular visitation to the moon will give, and Jack touched upon this, is we're going to get data. Meetings like this are going to nicely shout and argue about the science, but we'll learn new things. But this regular cadence allows the scientists to then go away, design the next generation instruments, and see them flown within a couple of years, and then rinse and repeat. And so that's going to be really exciting. The other thing I wanted to highlight here is the fact that I'm showing the first, as Maria touched upon, we have contracted for 3 missions, IM1 to IM3, that will go over in the next couple of years. But our own company goal is to try and have a cadence of at least 1 flight a year. And you can see that for the first 3, you can see the NASA payloads that were part of the task orders. But when CLIPS was started, one of the goals was to see if there was a commercial market there to have instruments flown. And you can see, but not just with us, but with the other companies, that they, each of our landings has definitely, a mixture of NASA and, most importantly, in a way, non-NASA payloads, which is a healthy, hopefully, a healthy sign that this can grow. And the Holy Grail, in a way, would be to do a landing without any NASA payloads, although we're always happy to take them. So our initial lander is the Nova C, and you've seen some pictures of it today from some of the people who were flying their payloads. The key takeaways is that this lander can can go anywhere on the moon with small modifications. It can carry roughly 130 kilograms, but that is expandable depending on a need, and a wide variety of mounting options depending on what you need, what your payload actually needs, whether it needs access to the surface or a certain visibility, etc. We also have derivatives that are planned. So the Nova D is then sort of the follow-on from Nova C when there is a payload need, and that can go all the way up to 2,500 kilogram class payloads. So just one very quick slide on IM1. This just, this highlights again the NASA payloads that were part of the task order, but also it shows the variety of commercial payloads that we are flying. So for mobility services, we're well aware that when customers come to us, they often want their instrument. It is required to have mobility of some kind. That can either be a rover or, as we heard earlier, the hopper. With the rover, we have partnered with a company called Lunar Outpost that can provide. They have a suite of different rovers. We're already flying the MAP rover, which is on their smaller end, that can take payloads in sort of the 12 kilogram, 10 kilogram class, but they have much larger rovers if the payload needs it. But also part of our mobility services is the fact that we don't just fly the rovers from Lunar Outpost. The Nova C is designed such that we can, each individual lander delivery can fly a variety of multiple rovers. And no matter how many times you give it, you always find one spelling mistake. I'll leave that as a test for the reader or the people taking photos. Right. So I won't go much on this, but Trent gave you some nice details on the hopper. I think the hopper is an incredibly exciting example of a platform that will allow science that couldn't have previously been thought of. Particularly sort of the idea of going into pits or lava tubes, as well as to very rapidly going to places that you can't get to with a rover, with a variety of different flight profiles, depending again on what your data needs are. A key capability is our orbital drop-off capability, and I'm going to talk a little more of this at the end about a couple of projects that we are working on. So we can drop off payloads in a nominal 100-kilometer circular orbit before landing. We can also drop off larger payloads in a translunar injection fairly soon after launch. Part of what we've developed for our infrastructure, we realized early on the need to be able to get large volumes of data back and not to be dependent on DSN. So we have initiated, we have essentially a global ground system network where we have contracts with various large dishes around the world so that we can provide near 24/7 downlink for our data. Also, starting with the second mission, IM2, we're going to start to drop off our own communication relay satellites, again, which decreases the load on satellites or things on the surface for getting their data back. So, so my last two slides are a couple of opportunities I wanted to share with the audience of things that we're thinking about. I'm checking. Which that, you know, and hopefully that you will have an interest and will want to reach out later to chat. So one of the data by orbiter. So we got to thinking about the fact that we can drop something off in a nice mapping orbit, combined with the emplacement of our communication relay network. It got us thinking about, could we acquire the next, so essentially the next generation of data sets that the community wants, using a much more modest spacecraft and therefore doing it cheaper than, if you like, a classical lunar orbiter mission. And we, as we all know with the moon, the good thing is data, the same, in some ways, the same data sets are of interest to multiple types of consumer. We have the exploration community, we have the resources community, we have the science community. I throw out here examples, sort of very high resolution, multispectral or hyperspectral data, or topography, or neutron or thermal. Those are all data sets that if we could acquire data that is better than what we have right now, that could be of use. So we're exploring the possibility of essentially flying our own small sat to acquire those kind of data sets. Related to this is also we're thinking about, could we either do an independent mission, or again, a significant part of a lander delivery is a multiple CubeSat mission. Apologies for the acronym, I just couldn't help myself. So the idea here is, I think the Artemis 1 showed there is an interest in flying planetary CubeSats. And again, our logic was, if we could actually drop a CubeSat off in a nice mapping orbit as a starting point, then that allows the CubeSat, which obviously by definition have limited power and propulsion and communications type capabilities, does that allow the community to be innovative and help acquire some really interesting data for lunar science using a CubeSat platform. And indeed, earlier in the session, we heard about Argo Moon a couple of days ago. We had just heard about Lumio. That's a perfect example of, is there an advantage to people, to companies or universities who would like to do a CubeSat, essentially being dropped off and be able to use a communication network? We think that this allows the community to be very innovative. It helps grow the next generation of scientists, engineers, because they can, it's something that a university level entity can fully accomplish, and giving scientists and engineers proper hands-on experience. Obviously, it's a great international collaboration opportunity, but also it could be multidiscipline. It doesn't just have to be for lunar science. CubeSats could be dropped off in orbits other than low lunar orbit. And my watch says 9 minutes something, so I'm done. Thank you.